Hey everybody, let's finish up this discussion now. So we're going to wrap up REST. We'll do a little compare and contrast and call it good for the week. So basically, again, with REST, the idea is that we're using a URI to access all of our resources. Think of it just like a URL that you're putting into your browser, and that's how we're going to access them. The idea is that humans and programs will access these services in the same way. Right? Why can't programs just talk to a web server like we can? And that's the exact idea here. We send a request to our server and we get some resource back. In this case, in this little example that I yoinked off of Google, we're getting a JSON response back. So to kind of go over some of the bits and pieces of REST and why it's good versus bad. So we basically have this idea that everything is linked. So we're following the web idea, web paradigm, that everything is linked together. And that makes all of our resources fairly easily accessible. Now, with using HTTP, we have access to those standard operations: get, update, delete, destroy, right? All of those common terms that we have all come to know and love at this point. Now, what do we get out of that? Why would we use this over SOAP, for instance? Well, it's addressable, meaning that it's very, very easy to find everything, which is always a big problem in massively networked systems. It is stateless, which is something that we've been, ideally striving for with our web interpretation. It has pros and cons, obviously, but we've talked about that already. And everything is connected to each other. Again, it's all linked. So let's start talking about addressability. So everything has a name, and with that name, we have a way to reach it. So what does that get us? Well, if I have a particular URL, for instance, that gets me some resource, again, let's get the temperature of some device, I can bookmark that in my browser, right? I don't need to remember a very specific call or pop open a program and hit the button to execute it. I just go to that link. So ideally, it makes it easy to find. And with that, we get browser history. We can link up with RSS feeds if we want to go that route, which RSS tends to be XML if you've never played with that. And if we're starting to get into the idea of caching, well, the name's already baked into that as well. So think of a URL slug. So here is a random one that I came up with: my.server/getData/IoT device/living room. Intuitively, I know exactly what this is, right? I, as a human, know. And if I am the programmer figuring out services that talk to each other, it works just fine in there too. It's very descriptive. Now, in this case, though, you want to avoid synonyms. You want to make things as explicitly clear as possible, right? If I were to say room or room one, that means nothing to me. Living room makes a lot of sense, though, right? IoT device, pretty common. Any of my devices are IoT devices if they have a network card, right? So that's probably a bad example there. But it's all uniquely addressable is kind of the goal here, and easily accessed. So the other one, statelessness, again, we've talked about this multiple times, but what do we get out of that is that we don't need to make sure that our server is in the exact state for the client to get something. And what I mean by that basically is, if you think of some of these applications that we've set up, you need handshakes to occur back and forth from the client and server, right? Client sends a request, server gets a response, client logs in, server sends a response, you're logged in. Client sends this request, server gets this. Now we are in this particular state of our program. Well, if we are stateless, we don't have that entire rigmarole to go through. We just know in the exact, with the URL slug that we're sending, that we are in the exact correct state. Idea here is that we are kind of reducing the complexity of our systems. We are also kind of reducing the number of faults, of logic faults that could occur here as well. Again, let's push off state to the client side. All right, other thing here, connectedness. So basically everything is linked. If you have any interest in something called the semantic web, you kind of know that connectedness is a goal where if I have one word, I can figure out every single other word that it's connected to. This is great for like search and things like that. If you don't know anything about the semantic web, that's fine. Basically, the idea is that everything is interconnected. So here, if I have a resource called bees, I have all of these adjectives and verbs related to bees that I could look up pretty easily. Same idea would be here. If I have a call to get data, maybe I will just return a list of every single device in my system. And then here I've got IoT device 1, IoT device 2, 3 and 4 and 5 and so on. All the different rooms that I've got. Basically, if everything's connected, we can easily search, we can easily find things, and we can, ideally have a very well-connected system that there's no pieces that are going to get lost in the shuffle. Again, think of a whole bunch of separate services trying to interoperate with each other. They all need to be able to talk. All right, and with this idea of connectedness, so I wanted to give you a couple of visuals here of different connectedness levels. So A would be a web service by itself, so a typical RPC where it's not connected to anything, it's not addressable, it's just a program running out there. So it's probably hard to work with, right? I need a very specific way to access this thing if it is accessible at all. B, I've got 4 services here, but they're not connected. So this could be a type of setup where they're all operating in parallel, but they don't know each other exist. And hey, maybe this service has some information that the service needs, but because they don't talk, there's no way for these services to know that. And then this one has to figure out that information as well as here. See, everything's restful, everything's addressable and connected. We can discover each other. Ideally, life is good. Let's share information. All right, this is a bit of a summary slide here if we haven't gotten this at this point. But with our uniform interface, this is basically relating those HTTP verbs to our various RESTful operations. I'll kind of let you skim through this as well. And one I didn't talk about was post. Basically, this is we're getting like a sub-resource. Head would just return metadata of some resource, not the entire packet of information. But basically, all of our HTTP verbs have a RESTful analog. Other things we can talk about, safety and idempotence. Basically, with safety based on the verb, we're guaranteed to not make a change. Now, your RESTful application needs to enforce that, right? It wouldn't be good to implement a get functionality to your system and then have it update something. It's technically feasible to do that, but you shouldn't. But the idea is that if we're doing a get request, don't induce a change, but if you're doing a put, that's perfectly fine. Idempotence then basically means that if I make a put request because I want to update something, it's basically just, I can do this multiple times, like I can refresh by accident 500 times and the first change is going to be the one that takes effect and the rest of them aren't going to be basically ruining everything else in the system. Same with delete and update and all of these verbs that will actually change some of the representation. So the idea is basically, let's improve fault tolerance, right? Because we know users are going to click the button 50 times when it doesn't load immediately. All right, and then the last bit, this uniform interface that we have, ideally, and I'm not going to say this will happen every single time, but we can encourage emergent behaviors. And what that means is that we can possibly have a system where we get behaviors that we were never expecting to see when we wrote them. By having a flexible system that can react simply to inputs and outputs, we can start basically building up a much bigger system with all these separate components to make something that we never thought we could have before. Now, this could be good, it could be bad as well. It just depends on your setup and what protections you have in place. But just to kind of consider, let's say that I have a RESTful setup where I'm working with all my IoT devices, right? And now I'm getting temperature, I'm updating temperature. I add in a component to manage my HVAC system. So all of a sudden I can plug into my air conditioner, my heater and all that. Then I add on another component which can, if it detects a temperature change, it can kick on the air conditioner automatically. Simply by adding in this extra piece, it maybe reads the temperature, sees it's out of range, talks to the other one, kicks on the air conditioner. This system was never explicitly designed by me. It's just 3 separate services that are all now working together nicely because they have published APIs and I know how to work with them, right? So the idea is that we can effectively build a system of systems, either intentionally or unintentionally, but it is possible. So last bit here, differences. Now, W3C, the web services, this is a defined standard. REST is not a standard, but REST has a very rigorously defined set of actions and verbs that we can work with. Now, with the web services, so SOAP, UDDI, WSDL, we get a lot more capabilities than REST because, again, REST is a lot more basic and simpler. But that means that we also have a lot more to implement and a lot more application-specific things that need to be put into place. The rest then becomes smaller in memory footprint and resource usage. And it's a lot more extensible in that regard as well. Again, because we're just using common web terms here. Also, just as a pure happenstance, we don't see as much SOAP these days. You can obviously find lots of examples on the web of SOAP still being used. And if you are in an environment where you have legacy web applications, you probably will have to deal with SOAP. But pretty much everybody's moving to REST because it's just kind of taking over. So in terms of the actual last bit, so 2 last slides here. I keep saying this is the last bit. We didn't really talk caching, but this really highlights the differences here. So in a RESTful call, let's say I want to do a get program, some ID, and then some crew. Basically, I can cache this call, and everything is exposed via the HTTP header. So basically, this entire interaction is cacheable, meaning that we can push it off to the server and keep this as long as it needs to stay alive. In a SOAP call, everything is hidden behind a layer of abstraction. So the get call can be cached, but everything inside of the packet needs to be custom written, custom coded for caching to be enabled. That doesn't scale well. It's not going to play natively nicely with other systems just by default. We're going to need to do a lot of hand coding to make that work. Again, SOAP is fine. There's just a lot more going on under the hood. So with that, where can we cache? Well, we can cache at the HTTP level, at the application level, just depends what we want. But keep in mind that REST tends to be a little bit more easy to implement, honestly. So to end this discussion, enjoy your RESTful demos. I've got a couple of fun ones coming up for you, and hope you all have a good week. Bye, everybody.